Hello and welcome to this video tutorial. Today we're going to look at Unit 1, Lesson 5, Solving Linear Equations with Unspecified Constants. Please remember to pause or rewind the video as needed. Okay, what does this mean here? We already know what solving linear equations mean. That just means an equation with one variable where x is written to the first power. But unspecified constants. Well, what that means is you have an equation with pretty much a whole bunch of letters. You might have some numbers thrown in there, but you have a whole bunch of letters that are going to stand for certain variables, okay? This is very, very common and very useful in in some aspects of math, geometry, area, finding area and perimeter and volume, things like that, involve using equations that are formulas. Formulas are equations where you plug in certain numbers to represent those letters, and you figure out a solution to it, figure out a result. Physical science classes like physics and chemistry use a lot of different equations to essentially set up the concepts that you learn in those courses. So doing this kind of math and learning how to be good with this kind of algebra will definitely help you when you get to that physical science class. Let's begin. Part 1. When we look at the expression here, 3 times, and then it's x minus k, and then dividing that result by whatever w is, and then that's supposed to equal 4. So it says when that equation is solved for x in terms of w and k. So what that means is in terms of, it means your answer needs to have w and k in the answer. Its solution is which of the following? Show your work. Okay, so let's take the equation. Let's write it down. So we have 3 times x minus k, right, all over w, and that's supposed to equal 4. So if I look at the 3 things, I see x is being subtracted by k, that result is being multiplied by 3, and the whole thing is being divided by w. So I'm focused on the very last thing, which is the dividing by w. So that's where I'm going to begin. I'm going to begin by multiplying both sides by w. Cancels, cancels. And you can see this is the exact same math we did in lesson number 2 and 3 when we were solving using our inverse operations. Okay, now cleaning up what we have here, we can see on the top we have 3 times the quantity x minus k, and then 4 times w would just be 4w. Okay, now to get the x by itself, we have to get rid of the 3. Now 3 is being multiplied, so the opposite of multiplying by 3 would be to divide by 3. 3 cancels, and we have x minus k equals 4w. Well, the last step to get x by itself is to get rid of the k. Now, since we're subtracting k, the opposite of subtracting k would be to add k to both sides. Now, clearly, w and k are different things, so we can't just add them together and say it's 5. Well, that's not true because they're different things. You don't know what they are. So we have to leave them separately and different. So x would equal the 4w plus the k, and that's the result we should end up getting. Oh, I'm so sorry. I forgot. We had 4w divided by 3, so it's 4/3 w. 4/3 w plus k, which would be part 1. Okay, so part 2, solve the equations for x. It may help to make the equation with numbers and then solve it to the side to make sure you're not doing it with any mistakes. Well, you can do that if you want, but I urge you to practice. Use the inverse operation algebra we practiced in lesson 2 and 3, and let's apply it when we have nothing but letters, okay, and maybe a few numbers here and there. We can do this, okay? I have to get x by itself. Now, in order to do that, I have to get rid of the minus c first, then the multiplying by a, and then finally the plus b. So I'm going to start this whole process by adding c to both sides. Now, if I do that, I get a times the quantity x plus b, and then over on this side, I get d plus c equals d plus c. Now, in order to get x by itself, I need to get rid of the a and the b. Well, the a is being multiplied, so I'm going to divide both sides by a, like that. And I get x plus b equals d plus c divided by your a. One last step. We're almost done. I just have to get rid of that plus b. So the opposite of adding b would be subtracting b both sides. And I get x equals d plus c over a minus the b. Now clearly, since you don't have any numbers for these values here, you can't do a check. You can only do a check if you actually plug in numbers and substitute numbers for, let's say, a, b, c, and d, and then you could do an algebraic check to see if it's a true statement or not. But without actually giving numbers for a, b, c, and d, you wouldn't be able to do that. Letter B. Well, how do I get x by itself? Well, look at what's going on here. X is being increased by c. That result is being multiplied by e. The whole result is then being divided by b. So let's start with the opposite of that. The opposite of dividing by b would be to multiply by b, both sides. Cancels, cancels. Now, I get what's on the top. E times the quantity x plus c equals 2b. Again, I'm going to go ahead and divide away the e to both sides. And I get x plus c equals 2b over e. Okay, one last step. The opposite of adding c would be subtract c both sides. And I get x equals 2b over e minus c. You can see this is the exact same math we've been practicing. It's just with letters, no numbers. Okay, letter E. How do I get x by itself here? All right, so I'm going to show you a little technique called factoring. Okay, that's going to help us out a lot here. So the first thing I'm going to do is I'm going to take that term that does not have an x and I'm going to move it over to the right by adding d to both sides. That is a good first step. Now I get rx plus qx equals gc plus d. Okay. Now at this time, if you look, x is my common term. So x is my common factor right here. Well, what I'm going to do is I'm going to pull that common factor outside. Parentheses. Now what's left over? R plus Q. R plus Q is what's left over. It's kind of like the opposite of distribution. If I were to multiply it through, I get R times X and Q times X. Okay, so factoring is just the opposite of distribution. And that's equal to G times C plus D. Okay, is actually one step left. In order to get x by itself, you simply have to get rid of r plus q. Well, x is being multiplied times r plus q. So we have to do the opposite of that. We're going to divide by this product here of r plus q. to both sides, of course. Cancels, and you guys got x by itself. So x is equal to g times c plus the d all over r plus q. Now here, I got to do something similar to what I just did, but notice the x's are on opposite sides. So what I'm going to do is I'm going to bring these terms over here, and I'm going to bring the cx over with the 2ax. Okay, so here's how I'm going to accomplish that. So the first thing I'm going to do is I'm going to add b to both sides. That's the first thing I'm going to do. Okay, and rewrite this thing. We have 2ax equals cx plus d plus b. Now the next thing I'm going to do is I'm going to subtract the cx from both sides. That way I bring my x terms together. So I get 2ax minus the cx I brought over to the left equals d plus b. You have to keep everything separate because you don't know what these numbers are and you can't assume they're the same thing. But again, just like I did last time, I have a common factor of x. So bring it out. And then, of course, that's equal to d plus b. And then whatever's left over, 2a minus c, goes in parentheses. One last step, ladies and gentlemen, get the x by itself, and we're going to divide by 2a minus c. And therefore x equals d plus b over 2a minus c. Again, I realize these answers look very weird because it doesn't really make a whole lot of sense when you're dealing with letters and you don't know what the letters have, what the value for those letters are. But just please remember that these letters, they stand for something. They stand for a certain value of something. And when you actually plug numbers into them, it starts to resemble the math that you've been practicing. Okay, so please know that this is the same kind of math we did in lesson 2 and 3. Okay, now how are we going to go about doing this? Well, I kind of look at this and go, well, I need to bring the x's together, but one of the x's is inside parentheses. So I'm thinking the first thing you probably ought to do is distribute the right side there, and then we can bring things together. So zx on the left would equal 5. Now 5g times 2, well, the 5 times 2 would be 10. 5 times 2 is 10, and then gx. Minus, and then you're going to multiply 5g times the c, and you get 5gc. Okay, now the next thing I'm going to do is I'm going to subtract 10gx from both sides, like this. Okay, now if I do that, I get zx minus 10gx equals negative 5gc. We'll do the same thing we've been practicing the last few times. I have a common factor of x, so pull it out front. Everything that I did not highlight there goes on the inside, z minus 10. Minus 10g, sorry, minus 10g. Z minus 10g goes in parentheses, and that's going to equal negative 5gc. All right, now to get x by itself, it takes one last step. We're going to divide away what you see in parentheses there, and z minus 10g to both sides. So x would equal negative 5gc all over z minus, it's supposed to be a z, not a 2, minus 10g. Okay, little tricky looking, but it's the same math that we've been practicing over and over again, same algebra steps. Just looks a little weird when we're not dealing with concrete numbers. Now, in our final problem here, we have two fractions. Now, one of the best ways to get rid of a fraction is to essentially multiply by a common denominator of that fraction. Well, common denominators, now, lowest common denominator is one thing, but a common denominator denominator is the bottom, right? So common denominator is just the product of the two. Okay, so in this case, what's the common denominator? Look at your two denominators. Your denominators are b and d. So what's your common denominator? It is b times d. So what we will do to get rid of the fraction, we're going to multiply everything. Multiply each term by b times d, the common denominator. Okay, and we're going to see how this looks. Okay, so I'm going to take ax over b. I'm going to spread things out a little bit. Plus cx over d equals e. And what I'm going to do is I'm going to multiply each term by the common denominator of b d. Multiply everything. Now you have to multiply everything by this. Okay, everything. Now if I do, look what happens. The b part cancels here. The d part cancels here. And that's what helps get rid of the fraction part. What's left over? dax plus, here what's left over? bcx equals bde. Again, do your common denominator. So x is my common factor is x. So I'm going to pull it out front. What is left in parentheses? Again, BDE is on the other side. What's left in parentheses would be DA plus BC. Okay, now the last and final step to get x by itself is multiply by divide what is multiplied by x, and that's dA plus BC to both sides. So x equals BDE over dA plus BC. Okay, and our final page in the applications, we're going to look at two actual physics-related examples and how do we deal with the equations and rearranging those equations for certain variables. So part 5, in physics, the following formula, remember formula is just another word for equation. The following formula relates your distance above the ground, d, relative to how long, that's time t, the object has been in the air. So we get this equation, d equals, and you have a v sub 0 times t equals 1/2 a times t squared. Well, it says solve the equation for a, the acceleration due to gravity. So I have d equals, and this term right here, just so you know, this v sub 0, This is pronounced V naught, N-A-U-G-H-T. That's how it's pronounced. In a physics class, you would recognize that as the initial or starting velocity, the starting speed in the problem. That's not necessary for you to really understand that for the purpose of this problem. I'm just giving you some context. So D equals V naught times T plus 1/2 A times T squared. Now you have to get A by itself. So in order to get A by itself, you have to get rid of the V naught T, the 1/2, and the T squared. So I'm thinking the first thing that's easiest to get rid of is the V naught T. So let's start there. Or actually, one thing we could do to make it even easier, because a lot of times people just don't really like the fraction very much. So one of the things we could do is let's just multiply everything by 2, and we're not going to have a fraction anymore. Multiply everything by 2. 2, 2, and 2. And the reason why we're doing that is because if I multiply by the inverse of 1/2, the inverse of 1/2 is 2, and I don't have a fraction anymore. Now, what do I get, though? I get 2D equals 2 V naught T plus A T squared. So again, still solving for A. Okay, I have to get rid of the V naught T and the T squared. So how do I get rid of the V naught T? Well, I can subtract it to both sides because it's being added. The opposite of adding is to subtract. So I get 2D minus 2 V naught T equals A times T squared. And now in our final step here, we're trying to get rid of T squared. Well, T squared is being multiplied times A. So the opposite of multiplying would be to divide by T squared. You can see it cancels here. And there's our result. So A, and I can even factor out a 2 right here. 2, and then what's left over is D minus V naught T. And that's all over T squared. So there's our equation that's been rearranged for A, the acceleration due to gravity. Now what we'll do is let's actually find its value by plugging in a D of 80, a V naught of 50, and a T of 8. So we have 2 times, and we're going to plug in 80 for D, the distance, minus V naught is going to be the 50, so minus 50 times T, which is 8. And then we're going to divide this by times squared, which would be 8 squared. Okay, so evaluating this part here, we've got 2 times 80. Now, 50, 5 times 8 is 40, so 50 times 8 would be 400 over 64. Okay, now taking a look at that part, we're going to go 80 minus 400 is negative 320. So we have 2 times negative 320 over 64. Well, 320 times 2 is negative 640 over 64. Well, that gives you negative 10. There's our value for the acceleration due to gravity. The units, again, are meters per second squared, but we don't have to know that necessarily. We're just Again, doing the algebra behind this. In our final example, it says when traveling abroad, many of the units are different. For instance, the temperature is could be in Fahrenheit or Celsius, and there are as a conversion between the two that goes C, which is Celsius, equals 5/9 times F, which is Fahrenheit, minus 32. So using the formula, convert 50 degrees Fahrenheit into Celsius. Well, basically, we're going to plug 50 right in there for F and figure out what the Celsius degrees. So Celsius equals 5/9. I'm going to plug in 50. So let's go 50 minus 32 first. And 50 minus 32 is 18. Then you're going to multiply that times 5 and then divide that by 9. And we get an answer of 10 degrees Celsius. Now, the conversion into Fahrenheit can basically be done the following way. So we're going to solve the equation for Fahrenheit. So C equals 5/9 times F minus 32. So to get Fahrenheit by itself, we have to get rid of the 5/9 and then the negative 32. Well, to get rid of the 5/9, we're going to multiply by the reciprocal, which is 9/5 to both sides. So 9/5, 9/5. This cancels, and that leaves you with just F minus 32. So F minus 32 on this side equals 9/5 times Celsius on the left side. Well, your last and final step is to add the 32 to both sides, and there you have it. There's our equation for Fahrenheit. Fahrenheit equals 9/5 Celsius plus 32. So convert 50 degrees Celsius into Fahrenheit. So we're going to go and put 50 degrees Celsius in here and just convert and see what we have. So 9 times the 50 is 450 divided by 5 would be 90 plus the 32. Well, 90 plus 32 would be 122 degrees Fahrenheit. So these were just two examples from physical science, chemistry and physics related classes, where taking an equation, also called a formula, and you can rearrange that equation using the same algebra steps and the same algebra skills that we learned and practiced in lesson 2 and 3. A little challenging, but the math is still the same. I hope you found this tutorial to be helpful, and we'll see you next time.